Let's see what happens when C now sends a frame back to A as the switch has begun to build its MAC address table. This time the frame has a source address of all C's, a destination of all A's, and at this point, when that frame comes into port 2, what will the switch do? It has to ask itself a question. What's the question and which of the two addresses does it concern? It's going to ask itself, do I have an entry in my MAC address table for this incoming frame's source destination, the all C's address? Well, at this point in our walkthrough, the answer is no. So the switch puts one in, and this is what we end up with. We're looking at the MAC address table. We now see an entry for the all A's address and the all C's address. We also see both of them are dynamic, as we'd expect, and we see the ports off which each of them is found. Now, what is the next question the switch is going to ask itself, and about which address? And you know the drill here. It's already in the table. The switch now asks itself, do I have an entry for the destination of this incoming frame? And this time the answer is yes, because it's the all A's address, and the switch put that address in its table the first time A sent a frame to C. So this time the frame is only going to be forwarded. And that's how quickly the flooding begins to die down, that initial flooding when a switch comes online, because it's got to learn all the addresses, but once it does, you've got a lot of forwarding going on and not as much flooding. There is no need for the frame to be sent out fast Ethernet 0/3. No reason at all, and there is our forwarded frame. Then when A sends another frame to C, now it's forwarded again, where just a few minutes ago it was going to be flooded, but now the switch has an entry for the all C's address. So it uses that when a frame comes in on port 1, says, hey, I only need to send this out port 2, and that is the power of forwarding a frame. We really like that. Now, after a few minutes, everybody has sent some data, and we have this MAC address table where all of the 4 hosts have been heard from, all dynamic entries, and the very unusual circumstance of hosts A and B being found off the same port because of that hub. And this is a very unusual scenario, but it helps to illustrate that other frame decision, the frame forwarding decision. Because if A sends a frame to B right now, B is going to get a copy of the frame through the hub, because what is the hub? It's a multi-port repeater. That's all it is. The switch will also get a copy. So what's going to happen now? Well, for clarity, I have removed C and D from the walkthrough, and this is what ends up happening. Host A sends that frame. The destination is all B as well. The hub is not even reading that, because our hub is a layer 1 device. So it's just a multi-port repeater. It's like, hey, everybody, here you go. Everybody that's connected gets one of these. And the thing is, the host, the intended destination, host B, does get the frame, but so does the switch. And the switch looks at that incoming frame and it says, wait a minute. This is not an illegal action, but it's very unusual. And this is when a frame gets filtered, which is just another way of saying it's going to get dropped. And that's when the switch looks in its MAC address table and says, okay, the source and destination for this frame are both found off the same port, in this case fast Ethernet 0/1, and it's just going to drop the frame. That's all that's going to happen. So reviewing our 3 decisions here, and when they happen, forwarding occurs when the switch has an entry for the frame's destination MAC in its table, and that frame is going to be forwarded. It will be sent out only the port indicated by the MAC address table. Flooding occurs when the switch has no entry for the frame's destination MAC in its MAC table, and with flooding, the frame is sent out every port except the one it came in on. We don't get to say many nevers in networking. You've probably already caught on to that, but if you're new to it, there always seems to be an exception to the rules we have, but there is no exception to that. Frames are not going to go back out that same port. If a frame comes in a port, a copy is not going to be sent back out. Finally, filtering, we saw that. It's when the source and destination MACs are located off the same port, and the frame is simply going to be dropped. Now, flooded frames are not the only frame type sent out every port except the receiving port. Broadcast frames are frames intended for all hosts. And this is a MAC address you need to be very familiar with. It's the all Fs address. And if you're not familiar with how MAC addresses are constructed, where the Fs are coming from, You will see that shortly, but I do want to expose you to this now, that destination MAC of all Fs, either uppercase or lowercase, or maybe even a mixture, because case does not matter when it comes to hexadecimal, which is where those MAC addresses, how they're written. Now, I know you were thinking when we were doing our walkthrough, that's fine, but how long do those dynamically learned addresses stay in the table? Well, while static MAC address entries remain in the address table until they're manually removed, dynamically learned addresses stay in the table for 5 minutes. That's the default. And I usually say 300 seconds, not to be cute or show you my command of, knowing how many seconds are in a minute. But as you'll see, when we change that, the command actually uses seconds. That's something we got to watch out for. But 5 minutes, 300 seconds, however you want to put it. And that 5-minute timer is reset every single time a frame comes in with that particular source MAC address. So that is the end of our walkthrough about how a MAC address gets built. Coming up next, I'm going to show you, we're going to go back to that discussion we were having about static entries versus dynamic and what happens when a port goes bad and you have to just quickly move a cable to another port and how that works with a switch and dynamic addresses. I'm going to show that to you, and that's coming up next.